Osteology is simply the study of bones and the bone support structures. So what we are looking for in your skeleton is structure and support. And the other thing that we often forget about is the mineral storage component of it, particularly calcium and phosphate. And then the marrow that's actually going to help us store lipids and make red blood cells. So we have yellow marrow that's going to be associated with lipids and red marrow that's going to be associated with the blood cells. So in your system, we have to keep in mind that it's not just bones that make up your skeleton, but bones and ligaments and tendons and all of these cartilage points that we're going to have to keep in mind too. The other thing that folks often forget is that bone is still alive. Now, what we look at with bone tissue is taking cartilage and calcifying it. So we're looking at hardening that cartilage. And so when we look at having this cartilage available to the start of our skeletal system, it's because cartilage cells divide very, very rapidly. So it allows for very quick growth, replacement, and repair. But when we look at mature bone cells, known as osteocytes, these cells cannot divide. So we have to do all of the division and growth that we need at these cartilage plates, or what you may know as growth plates. When we look at you in development, so the left-hand side of my screen here is actually before you're even born. So this is fetal development. The blue is cartilage. The cream color is bone tissue, or the osteocytes. So you see when you're born, your bones are very cartilaginous, meaning that they're almost sort of squishy. This is important for you because we need those bones to be flexible and a little bit pliable during birth and in the first few months of life. And in the first couple of years, we need some amount of protection for those bones. We don't want to be breaking a bone every time you fall down when you're trying to learn to walk. That's not going to go very well. So as we go through childhood, we see less and less of that blue, but you notice the growth plates remain. And these will remain until you reach complete growth stages. So when you finally stopped growing, that's when we look at all of that cartilage turning into and being calcified into what we know as osseous tissue or osteocytes. So this actually makes up very, very little of your bone structure itself. We look at cells only making up about 2% of the actual bone mass. Most of it is going to be calcium when we look at this. And the reason is because the cells form structure. So they're going to give us structures such as this diaphysis that I have here, the central part of your bones, or the epiphysis we look at as part of our less dense spongy bones, and I'm going to show you the difference in a minute. But the whole idea with these cells is to form structures like a central cavity where we're going to store marrow and nutrients and other things that we need. So you see the difference here between this spongy bone, looks very porous and open, compared to the compact bone, which has very close, tight cell structures associated with it. Now, when we look at this, why would we have any spongy bone? It looks very dangerous as far as it would break easily, right? Well, you have to keep in mind that we have to keep a fairly lightweight skeleton. So from that standpoint, having these more porous bones not only allows us to keep the skeleton lighter, but it also allows us, as you see here, to bring in blood vessels. And the reason we need to get blood vessels into your bones is because we've got to be able to get to the bone marrow. So in this case, yellow, which stores fats. But we also are going to have red bone marrow that's going to be producing blood cells for us. So if you make blood cells in the middle of your bones, you have to be able to get them out to the world, right? Out to the rest of your body.